In this next series of videos, we're going to be working with notes payable, where we're going to write a note for a certain amount, or somebody might come to their due date on our accounts receivable and then say, well, they can't pay. And so in that circumstance, they might write us a note payable, where they'd write us a note telling us that they're going to pay a certain amount of interest in addition to the amount that they owe us, and they're going to pay it in a certain amount of time. So before we get much into the journal entries and so forth for notes payable, we're going to work on finding the maturity value. So first of all, we're going to just do some problems to do that. So to find the maturity value, it's the principal times the interest rate, but then I also have to multiply it times the period. And how that works is that the interest rate is given in terms of years. If I had a $20,000 note and I were going to pay it back in 1 year, I would pay it at exactly 14%. So if I were to take $20,000 times 0.14, 14%, I would pay exactly $2,800 in interest. But that's not often how it works. Sometimes there'll be a fraction of the year. Sometimes it'll be more than 1 year, and so on and so forth. And this note is not for a whole year. It's only for 60 days. And so what I'm going to do is I'm going to multiply this amount times 60, and then I'm going to divide it by 360. And I'm going to put a formula on here that shows exactly what I'm doing here. I'm going to take $20,000 times my 14% interest, and I'm also going to multiply it times 60 days, but I'm going to divide this 60 days by 360. Let me put the fraction up there. There's my fraction. That's the math that I'm going to do to find the maturity value of this note, or at least the interest. So it's 20,000 times 14%, and then I just multiply times 60, and I divide by 360. And some of you probably noticed that there are really 365 days in a year, not just 360. And I'm sorry, that's just the way things are done in finance. We just say it's 360 days, and we pretend those other 5 days aren't there. And so this works out to $466 and a bunch of cents. And I'm just going to round to the nearest dollar for this one. So it's $467. And so this is the interest amount. This is not the maturity. This is the interest. That's how much interest someone will pay on this note. And the maturity value is the principal, is $20,000 plus the interest. And I can just do that in my head. That is the maturity value. So now I have to figure the maturity date as well. And this seems easier than it really is. March 15, 60 days later. I can count all those days. I can think, well, you see here, there's about 16 days left in March, and then there's 30 days in April, and then so this will be, mid-May. But actually doing the math on that is a little trickier doing it by hand than what you might think. And so I wanted to show you an easier method, which is to use a chart. This is a days of the year chart. The way this works, you can see January 1st is the first day of the year, and January 31 is the 31st day of the year. But then February 1 is the 32nd day of the year, so on and so forth. So you can see what it's doing. It's giving you what day of the year each day of the month is, so you don't have to try and do a bunch of math to figure out what that is. So I'm going to use this to solve this problem. When is this note due? It's due, it's initiated on March 15. That's the start date of the note payable. I want to find the day on the other end of the year. So what I'm going to do first is I'm going to look up March 15. March 15 is the 74th day of the year. Now I've got to add 60 days to that one there. So I'm going to start with 74 plus 60 days. That's 134. So the day that I'm looking for is the 134th day of the year. I can come back to my chart and I can find that 134. That's May 14, and it looks like about what we estimated it would be, about mid-May. So date is going to be May 14th. All right, so now I know the maturity date of that particular note. Next, I'm going to just move on and do one more here, or I'll do the rest of these with you. So a 15,000 40-day note given on September 10 at 16% interest. Well, this is really just working the formula. I'm not going to write it on the sheet this time, but I'm going to do something much like this. I'm going to take $15,000, multiply that times the interest rate. I'm going to multiply that by the number of days, but I'm also going to divide it by 360 so I can get that fraction. And that works out to $266 or $67 in interest, but then of course I'm going to add in the principal, $15,267. There's my principal plus the interest. This is the maturity value again. And then we've got a 40-day note given on September 10. Find September 10. There's the 10th of September. This is the 253rd day of the year, plus 40. So it's going to be due on the 293rd day of the year. Come back to my chart here. 293, that's October 20. So now I found the maturity value and the maturity date. All right, next problem here. This one's a little bit different because I've got months instead of days. So, first of all, for the fraction, let me write this on here. $14,000 times the interest rate, which is 8%. That's in the usual times. Times the interest rate times. And this is going to be another fraction, 4/12. Let me put that on there. There's my formula, 4/12, because I'm not doing it for a full year. I'm only doing it for this fraction, 4 months of a year. So let me do the math on that one. 14,000 times 8% times 4 divided by 12. There. It's 373. I round down on that one. That's my interest there. And my maturity value is going to be 14,373. I can just do that in my head. And now I need to find the maturity date as well. This is April 20 and 4 months. This is done differently than days. I can just count the months, and then I'm going to put it in the same day 4 months from now. So I've got April, then I've got May. That's the first month. May, June, July, August. So the maturity date is going to be August 20th. So here is going to be maturity value. And then last but not least, we're going to do this one here. This one's a little bit interesting, and I'll show you why in just a minute. We've got a $2,500 note at 14% interest, and it's a 90-day note. So this one, again, these calculations are pretty straightforward. We've done stuff like it before. We've got 2,500 times 14% times 90. Since it's in days, we're going to divide it by 360. This one here is going to have, we'll say $88 in interest. So $2,588 is the maturity value. Alright, so now we have to find the maturity date on this one. And it begins on November 20. So let's go to our chart here. November 20. There it is, the 324th day of the year. 4th day of the year, we're going to add 90 days. 414. And of course you'll notice there are not 414 days in a year. We've run out of days. So what do? And the answer is we just subtract 365 days. So we're going to take 414 minus 365, and that brings us to which day of the year it's going to be. It's going to be the 49th day, which is February 18. All right. So now also a word of caution. You'll notice that this particular chart is for a non-leap year. If you're working with a leap year, or if you're going into a leap year, you're going to need to find a different chart. You can find those charts as well, or you can simply add one to every day after February 29th. So we've figured the maturity value and the maturity date of a series of problems here, and now it's time to start doing some journal entries. We'll do that in the next video.